right, the other day we covered section 7.1. In section 7.1 we talked about graphing quadratic functions in standard form, in vertex form. Today we're going to talk about graphing quadratic functions in standard form. So remember what we did the other day. We might have had something like y equals 2 times x minus 3 squared minus 4. So this is what we did back in section 7.1. The first thing we noticed is that was not a linear function. What told us that was not a linear function? It's got an x squared in it. When we had something called with an x squared in it, we called that the graph is called a parabola. The function is called, begins with a Q, quadratic. The function is called quadratic. That's a quadratic function. When you graph it, you get a parabola. The most important point on a parabola was the vertex. And what we learned back in section 7.1 is that we should be able to look at that equation and without doing really any work at all, we should know what the vertex is. So where's the vertex of that function? What's that? It has something to do with this number, which we called h, and that number, which we called k. So what does this minus 4 outside of the parentheses do to the graph? Nope. This outside the parentheses was up and down. And up and down worked the way you think it should. So a minus 4 tells us our vertex is going down 4. So our y number on our vertex should be negative 4. And the number inside the parentheses here, this controlled the left and the right. And we saw that left and right kind of worked backward. A minus 3 moves the graph which way? Right 3. So our vertex should be 3 comma negative 4. And we go ahead and we can start drawing the graph now. So we got 3 to the right, 4 down. What do you mean we don't square it? That's just to get the vertex. That's correct. Now we're going to build a little table, and as we build a little table and plug numbers in, yes, we're going to have to do the squaring. Okay? So the general idea was these numbers h and k tell us where the vertex is. What about this number 2? What did that number 2 tell us? That controlled how wide or how skinny it was. Since this number 2 is bigger than 1, this parabola is going to be skinnier. A big number makes it skinny. And this also controlled direction, didn't it? Since this number is positive, the vertex is going to go which way? Up. Okay, so what we did now is we built ourselves a little table. And we picked 4 numbers. We picked our favorite 2 numbers bigger than the number 3, and our favorite 2 numbers smaller than number 3. What were our 2 favorite numbers bigger than 3? 4 and 5 are usually our favorite numbers bigger than 3. And then we pick our 2 favorite numbers smaller than 3. 1 and 2. Okay, so now we've got to plug in 4. If I plug in 4, I have 4 minus 3. 4 minus 3 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 4, negative 2. So there's where you have to do the squaring when you start plugging your numbers in. Now I plug in 5. 5 minus 3, 2. 2 squared. 4 times 2, 8. 8 minus 4 is 4. So I have 4, negative 2. And notice I didn't put scaling on my axes, but I am labeling my points. So that gives a scaling on the graph too. You can do one or the other. You can either scale your axes or label the points like I am. And then we have 5, 4. And then we saw we really don't need to go through all the effort of really plugging in 1 and 2. When I plug in 2, what should I get for an answer? I should get 2, negative 2. And when I plug in 1, what should I get for an answer? 4. And we saw that parabolas had that nice symmetry property. That if I go one step to the right of the vertex or one step to the left of the vertex, I get the same y value. All right, so we draw our parabola. There it is. Questions on that? Okay, so what we're going to do today is something very similar, except our parabolas are going to be given in a different form. We might have something like y equals x squared plus 3x minus 4. That's called standard form. So standard form, your equation will look like y equals ax squared plus bx plus c, where a is not the number 0. And we talked about this the other day. How come a cannot be the number 0? Well, what happens if a is the number 0? What's 0 times x squared? 0, so I'm left with bx plus c, and bx plus c would be a line. It would be a linear function. Okay, now the first thing we need to do is, well, the first thing we really want to do is we really want to find the vertex. That's the most important point. Your author, J. Lehman, has a technique for finding the vertex that I've never seen in any other book, and I like it a lot. I actually had dinner with him the other night at the conference. He was there. I've known Jay for many years. Seen him at many conferences. Told him how much you all love his book. And, no, I'm just kidding. I did actually see him. All right, so here's what we do. Here's how he says to find the vertex. Take your equation, x squared plus 3x minus 4, and set it equal to whatever the constant is. Since the constant here is negative 4, we're going to set it equal to negative 4. So whatever that constant is, you set the equation equal to that constant. And then what you do is you solve that equation. So how would you solve that equation? You would add 4 to both sides. That's right. This is a quadratic equation. We know to solve a quadratic equation, we want to have 0 on one side. This is what we did right at the end of chapter 6. This was the last section in chapter 6. So we add 4 to both sides. We have x squared plus 3x equals 0. Okay, so we took our quadratic equation. We got 0 on one side. What do you do next? You break it up. In the fancy math word for break it up is called factor. Okay? And how would you factor that equation? Take out an x. So I'm going to have x times x plus 3 equals 0. So that gives me x equals 0, or x plus 3 equals 0. The left-hand one is already solved. X equals 0. That's already all by itself. This one will give me x equals negative 3. Here's what that gives us. That really gives us 2 points on the graph. Unfortunately, neither of them is the vertex, but we'll see how to get the vertex here in just a minute. If x is 0, what's the y number? Negative 4. Y, if x is 0, y is negative 4. Plug 0 into the equation, you get 0 plus 0 minus 4, that's negative 4. And what do I get when I plug in negative 3? You get negative 4 again, don't you? Why do you get negative 4 again?
Negative 3 greater than 9 plus 3 times negative 9.
Okay, that's the hard way to do it. The easy way is, didn't we set it up so that we knew our y number was going to be negative 4? That's what we solved, didn't we? When I plugged in negative 4, I plugged in negative 4 for the y value, didn't I? So here I have y equals negative 4. I have x equals 0, x equals negative 3. So I have the point 0, negative 4. That's right about there. and I have x is negative 3, it's over here, y equals negative 4. Okay, like I said, we have 2 points, but neither of them is the vertex. Where's the vertex? Halfway in between, isn't it? That goes back to what we did up here when we have our symmetry property. Notice this had x equals 4, and this had x equals, I didn't label this one. That should be 2 comma negative 2. This has x equals 2 and x equals 4. Where's the vertex? X equals 3. It's halfway in between. Or I could use these points. This one has x equals 1 and x equals 5. What's halfway in between 1 and 5? 3, and that's where our vertex is. So what this technique does, by setting it equal to the constant, it gives us 2 points at the same height. Where does the vertex have to be? The vertex has to be halfway in between. So what's halfway in between negative 3 and 0? Negative 1.5. So the vertex is going to happen at x equals negative 1.5. But then I also need to know the y number. How am I going to find the y number? Plug it in. So in this case, I'm going to grab a calculator. Not real good at plugging in negative 1.5 and squaring it and such in my head. Let's see. Negative 1.5 squared plus 3 times negative 1.5 minus 4. The y number is negative 6.25. So there's negative 4. Negative 6.25 would be a bit lower. Negative 1.5, negative 6.25. And there's my graph. What I did to find the y number is I just took my x number. My x number was negative 1.5, and I just plugged it into the formula. So I had this formula here. So I have negative 1.5 squared plus 3 times negative 1.5 minus 4. So that's negative 6.25. Other questions on that one? All right, let's try another one. Y equals negative 2x squared plus 4x plus 7 maybe. All right, so once again, we recognize we have a quadratic function. What makes this a quadratic function?
X squared.
It's got an x squared. We notice our quadratic function is in standard form. It's not in vertex form. So our technique for finding the vertex is we take the equation negative 2x squared plus 4x plus 7, and we set it equal to what? We set it equal to, not negative 7, 7. Whatever this number is right here, you make that number over there be exactly the same. Always exactly the same. I subtract 7 on both sides. Negative 2x squared plus 4x equals 0. So I have a quadratic equation. I get 0 on one side. Now what?
Factor.
Factor. How can you factor that? I can take out a negative 2x. Okay, that's a good idea. Negative 2x times x minus 2 equals 0. We end up with negative 2x equals 0 or x minus 2 equals 0. What's the answer to the first equation? X is 0, because negative 2 times 0 would give me 0. X equals 0. And the second equation, x equals 2. Okay, so we have 2 points on our graph. What are the 2 points we have in our graph? X is 0, y is 7, because that's the number we set it equal to. So I have 0, 7. X is 2, y is also 7. So 2, 7 is right here. So there's 2 points on our parabola. 2 points that are exactly at the same height. They both have y equals 7. So where's the vertex going to be? Halfway in between. What's halfway between 0 and 2? 1. So our vertex is going to happen at x equals 1. I take 1 and I plug it into my formula. I get negative 2 plus 4 plus 7. How much is negative 2 plus 4 plus 7? 9. Negative 2 plus 4 is 2. And then 2 plus 7 is 9. So I got 1 comma 9. That's right about there. And this parabola must go down, doesn't it? Because my vertex is above those 2 points. What made this parabola go down? This first number right here. When this first number is negative, the parabola is going to go down. When that first number is positive, the parabola is going to go up. Questions on that? All right, here's one for you to try. Y equals... Oh, I don't know. Anybody got a good number? 7? 7. Oh my, going crazy on me. 7x squared. Let's see if I can come up with a number to make it a fairly nice vertex. How about minus 14x plus 2, maybe. All right, so it looked like pretty much everybody had this. You took 7x squared minus 14x plus 2, and you set it equal to 2. You always set it equal to whatever the constant is. That gave you 7x squared minus 14x is 0. You factored out the 7x. You got x equals 0, x equals 2. Start drawing your picture here. Oops, that wasn't very straight. 0, 2. 2, 2. What's halfway between 0 and 2? 1. So our vertex is going to happen at 1, comma. I plug 1 in, I get 7 minus 14 plus 2. That turns out to be negative 5. 1, negative 5. My parabola opens upward. Should my parabola open upward? Is that correct? Yes. How do you know your parabola should open upward? The first number is positive. Also, that number is 7, which tells you your parabola should be very skinny. Should be tall and skinny. Okay, questions on that? All right, well, it turns out you don't have to go through all this process every time. So what we're going to do now is we're going to find a general formula for vertex. So let's just say I have a quadratic function in standard form, y equals ax squared plus bx plus c, but I don't know what any of the numbers are. All I have are letters, a, b, and c. But I want to find the vertex still. How would I do that? I take the equation and I set it equal to c, whatever that number is over there, right? So I would take ax squared plus bx plus c, and I would set it equal to c. That's what we've been doing each time. I subtract c on both sides. I get ax squared plus bx equals 0. Now I need to factor that equation. Can I factor? I can take an x out, can't I? I have ax squared here and bx there. I have a common factor of x, don't I? So I can factor an x out. And I'm left with ax plus b. So this one gives me x equals 0. And here I would have ax plus b equals 0. Ax would be negative b. I subtract b on both sides. And then I divide by a. So x equals negative b over a. So think about what I have. I have 2 points. One of them has x equals 0, and one of them has x equals negative b over a. Where's the vertex? It's halfway in between those 2 points. That's correct. So what's halfway in between 0 and negative b over a? Well, how do you find halfway in between 2 numbers? You add them together and you divide by 2. So the vertex is going to happen. I add those 2 numbers. I take 0 plus negative b over a, and I divide by 2. And this is going to be the x number of the vertex. What's 0 plus negative b over a? Negative b over a. So we have x equals negative b over a over 2. How do I take a fraction and divide by a number like 2? How do you take a fraction and divide it by a regular old number? You think of 2 as being 2 over 1. You think of 2 as being a fraction. Then how do you divide 2 fractions? Multiply by the reciprocal. So we're going to have x equals negative b over a times 1 over 2. So that's negative b over 2a. So this is known as vertex formula. For any parabola in the standard form, the vertex will happen at x equals negative b over 2a. Then how do you find the y number? You're going to plug it into the formula. Whatever number you get right there, once you figure out that number, you're just going to go ahead and plug it into the formula. All right, so y equals, somebody give me a nice quadratic function. 4x squared plus 16x minus 8. You now have 2 choices. Choice number 1 is you can take this equation, you can set it equal to negative 8, and you can solve and get your 2 points, and then find the vertex by going halfway in between. Option number 2 is you can find the vertex first. To find the vertex, we use x equals negative b over 2a. In this case, what's the b number? B is 16. So what's negative b? Negative 16 over, what's the a number? 4. So 2 times 4 is 8. So this is nice. You picked some very nice numbers because negative 16 over 8 turns out to be a nice number. It is negative 2. So the x value of the vertex is negative 2. Now we need to find the y number. So to find the y number, I'm just going to take negative 2 and I'm going to plug it in. So that's 4 times negative 2 squared plus 16 times negative 2 minus 8. And I'm going to grab my calculator. 4 times negative 2 squared plus 16 times negative 2 minus 8. I get negative 24. All right, so I can start graphing my parabola. Negative 2, negative 24 is way down there somewhere. Oh, so far down you can't even see it. There it is. Now what I would like, at a bare minimum, I would like to have 1 point to the right of the vertex and 1 point to the left of the vertex. 2 points would be better, 2 points on the right, 2 points on the left. But as a bare minimum, you should give me 1 on the right and 1 on the left. So, what's your favorite number bigger than negative 2? Negative 1 is not your favorite number bigger than negative 2. 0 is your favorite number bigger than negative 2. Why is 0 your favorite number? Because 0 is always the easiest number to plug in. What do you get when you plug in 0? Negative 8, because you get 0 plus 0 minus 8. Negative 8. So I have 0, negative 8. What's your favorite number smaller than negative 2 to plug in? Which one? Negative 4. Excellent decision. Why is negative 4 your favorite number to plug in? Favorite number smaller than negative 2? Perfect. When I plugged in 0, how many steps did I go to the right? 2. If I go 2 steps to the left, what's my y number going to be? Exactly the same, isn't it? So I don't really need to go through the work of plugging in negative 4. When I plug in negative 4, I know my answer is going to be negative 8. That's why negative 4 is your favorite number smaller than negative 2 in this case. It's the symmetry property. I started at negative 2. When I plugged in 0, that means I went 2 steps to the right. When I went 2 steps to the right, I got a y answer of negative 8. So I know because parabolas are symmetric, when I go 2 steps to the left, which puts me at x equals negative 4, I'm also going to get y equals negative 8. I will get exactly the same y number. So how many points do you really need to find? 1. Once you find 1, you really get another one for free, don't you? That's one of the beauties of parabolas. Once you have 1 point, you always get a second one for free. So I have negative 4, negative 8. And I can draw my parabola. Questions on that? All right, the last thing we have in this section they're going to give us some data. And from data, we're going to find equations. All right, so I'm just going to copy a problem out of the book here. We have year in this column. And in the other column, we have number of unemployment insurance claims. Number of unemployment insurance claims. And this is in millions. So we have 2004, 2005, 2006, 2007, and 2008. 3.1, 2.8, 2.5, 2.6, and 3.0. What's the first thing you notice about that data? The numbers went down for a little while, and then the numbers turned around and went up. So do you think this data is going to look like a line? No. Do lines go down for a while and then turn around and go up? No, certainly not. I do not think this data would be very much like a line. I think using a linear equation would be a very bad choice. What do you think it's going to look like then if it goes down for a while and then turns around and comes back up? A parabola would be a reasonable one, wouldn't it? The data goes down, turns around, comes back up. That looks like a parabola to me. What we want to do is we want to find an equation for this parabola. Any thoughts on how we could do that? Option number one, actually it's going to be option number two because we're going to do this one second. Option number two would be to use our calculator. We could type this data into our calculator and then we wouldn't use linear regression. Rather, we would use quadratic regression. So that's option number two. We'll do that one second. We'll see which one is better. Anybody get another option? Well, first off, to make life a little bit easier for myself, I'm going to call that 0. 2004, that's when we started, that's year 0, just so I can work with smaller numbers. We did this a lot with linear equations too when we had data. We would call the first one 0. So this one becomes 1, 2, 3, and 4. So let me ask you a question. Looking at that data, where do you think the vertex is? Probably the vertex happened in year 2, which is 2006. Why do you think that's the vertex? That's the lowest point, isn't it? So the lowest point is going to give us our vertex. Or if it was a parabola opening up, if it was a parabola opening down, if it was an upside down parabola, we would look for the highest point, and that would be our vertex. All right, so I'm going to use y equals a times x minus h squared plus k. What formula is that called again? That's called vertex formula. Do we know the vertex? Yes, the vertex is x is 2, y is 2.5. So, which numbers are these in this equation? H is the number 2 because our vertex is shifted 2 places to the right. And k is the number 2.5 because our parabola is shifted 2.5 to the right. So, without doing a lot of work, I know y equals a times x minus 2 squared plus 2.5. But I don't know the a number yet, do I? Okay. Any thoughts on how to find the a number? What's that? No, I don't think so. I think what I want to do to find the a number is kind of like back when we did linear equations. First we would find the slope usually, and then we would have to find the y-intercept. How would we find the y-intercept?
It would be the last number 0, it would be the 2 point.
Okay, if we were lucky enough, if we had 0, comma, something, then we knew our y-intercept when we were dealing with lines. What if we didn't know the y-intercept?
So we would have to plug in numbers.
We would have to plug in a point, wouldn't we? We're going to do the exact same thing here. To find a, we're going to plug in a point. The only one we can't use is we can't use the vertex, because we already used that one. So what point do you want to plug in? I would probably plug in 0, 3.1, because I think that's an easy one to use. Truth is, you could use any of the other points, whichever one you like. So 3.1 equals a times 0 minus 2 squared plus 2.5. So 3.1 equals, what's 0 minus 2? What's negative 2 squared? 4. So this is 4a plus 2.5. I subtract 2.5, 3.1 minus 2.5 is 0.6 equals 4a. So a is, I take 0.6 and divide by 4, 0.15. My parabola becomes, my quadratic function is y equals 0.15 0.15 times x minus 2 squared plus 2.5.
So if we end up going 4 divided by 0.6.
0.6 divided by 4. You would divide by 4 on both sides. So 0.6 is on top. All right, well, let's just look and see how good that looks. So I got to plug this data in. Boy, we haven't done that in a while. How do I plug data in? No, how do I type in these numbers into my calculator? Go to the stat button. Stat. Edit. That's where my lists are. That's where I can plug in my data. Clear that one out. Clear that one out. Oh, look at all those test scores. Clear that one out. That's what those are. 0, 1, 2, 3, 4. 3.1, 2.8, 2.5, 2.6, and 3.0. So type in my data. Okay, not quite graph yet, but you got the right idea. Not stat. What I want to do right now is I want to see a picture. You're right. So I go to second y equals to go to statistical plots. And I need to turn that one on. And I want that graph, don't I? And then my calculator's messed up here. I want L1. And then I would go zoom number 9, and that gives the statistical window. So there's my data. Does my data look kind of like a parabola? Yeah. And let's type in that equation that we found. We said it was 0.15 times x minus 2 squared plus 2.5. There's no line there.
Or like what did you do?
What did I do? Okay, first off, it's not called a line, it's called a parabola. I went to y equals, and I typed in this equation that we came up with, 0.15 times x minus 2 squared plus 2.5. Okay. Does that parabola fit the data pretty well? Yeah, it's okay. It should always hit 2 points exactly. It should always hit the vertex exactly. And in this case, we used that point. So it should hit those two perfectly, and it does. And what you're looking for is, does it come kind of close to the other ones? Yeah, it's not too bad. Not too bad. Okay? So there's one way to find the quadratic equation. We can find the quadratic equation by hand. Just like back a long, long time ago, we found linear functions by hand from data. We can do the same thing with quadratic functions. Now, the weakness of this is I really only used 2 points. And we saw back when we did lines, if we only used 2 points, sometimes your answer was pretty good, sometimes it wasn't. It was a lot better if you could use all the points. So, how do we do that? How do we find that quadratic regression thing? Stat. Calculate. Number 5 is quadratic regression. So if you think your data is in a parabola, you would use quadratic regression. If you think your data is a line, you would use linear regression like we did before. I want my x numbers are in L1, my y numbers are in L2. Well, for some reason my calculator had L2 there. My calculator set up in the new operating system. If yours is in the old one, it's going to look different. I'll do it in the old one in just a minute. So I would write down y equals, let's say we round to, how many decimal points do you want to round to? 2.13x squared minus 0.55x plus 3.14. I can't go to the old, won't let me do the old version. All right, let's just check to see if that one's better. Y equals 0.13x squared minus 0.55x plus 3.14. Is that equation better than the first one or worse than the first one?
It's kind of worse.
It's kind of better, it's kind of worse. In the sense that the first one that we did, when we did it by hand, it hit 2 points exactly. The new one that we found, let me just graph the new one here. Does it hit any of the points exactly? No, but it's closer to these other points than the first one was. And so that's kind of the trade-off that you make. Doing it by hand, your parabola will always exactly hit 2 points. Doing it using the regression, it's going to be closer to the points that you miss, but it's not going to hit any of the points exactly in general. Now we could use either of these equations to make predictions. For example, what if I asked you what's happening in the year 2010? You would plug in t equals, 2010 would be 6 actually. So you could take either of these equations, plug in t equals 6, and give me an extrapolation for what happened in the year 2010.